make it more look like the way that I showed you. Consider this function. What is the parent function of g of x? Parent function means just a function with no transformations. If I were to rewrite this and let's call this f of x, what would it look like? What would it look like? What is that same function but with no transformations? F of x is equal to 3 to the x. If there's no transformations, it would just be the base and the x. The base is 3. So they want us to list the transformations. Okay, transformations are based on A, H, and K, but Brian, you wouldn't just write A, H, and K. You have to tell me what A, H, and K are doing. What's A here? What's A? Good one. What's H? -2, and what's K? -1. Sorry, that's already bunched up. So what transformations are going on here, just like it was on the quiz? Is A doing anything? No. How about H? What's H doing? Go, Martha, go. Good. Translation. Left 2. And then, how about K? Translation down. See, so now this next part is where it gets like, when now they want us to graph, this is where it deviates a little bit from the way I showed you, right? Because from what I can tell, the other teachers just teach their kids to get these numbers and plug them in for x and take turns doing it. Fine, I'm not opposed to it. You do what you want. That's the way you want to do it. That's fine. I just think it's simpler to use transformations. So when I get to this part, I'll put the numbers I want to put in here. But let's, I guess, off to the side here. Let's come up with some numbers. So this is the same one we had in the quiz. So to start off, we can do 0, 1, 2, 3. 3 to the 0 is 1, 1 to the third is 3. 3 to the 1 is 3. 3 squared is 9, 3 to the third is 27. So these are the pairs I want to transform. What am I going to do to all the x's? Okay, but what's h? So I'm going to subtract 2 from all the x's. What am I going to do to all the y's? Okay, but a is only 1, so I'm saying specific to this function. Just take away 1. That's it. Okay, so if I go to the first one, which is 0, 1, I'm going to go 0 minus 2, Sam, and then 1 minus 1. And then that accounts for my transformations. 0 minus 2 is -2. 1 minus 1 is 0. So -2, 0. If you wanted to kind of use what they've given us here, put 0 here because that 0 goes with -2. That's why on your quiz I took out all these x's so that you wouldn't be confused. And I left it blank so you could pick the points you wanted to pick. 1, 3. Go to the 1, take away 2. And go to the 3 and take away 1. That gives me -1, 2. So -1. We had 2, 9 to start with. Go to the 2, take away 2. Go to the 9 and take away 1. That gives me 0, 8. 8. Now, if you can tell though, if if we were to do the same thing with 327, all I would be doing with the 27 is taking away 1, but that's going to give me 26. It's not going to fit on the graph that I've been given. So I always prefer 4 points, but 3 points would be fine. Where's the asymptote going to be at? Ingrid, where's the asymptote going to be? Say it better. Say it better. Good. Y equals -1. So I'll find -1. Draw a little horizontal line through it. And I prefer 4 points, but 3 points would be fine. -2, 0. Remember, this is just a sketch anyways. It's never going to be perfect. -1, 2. And then 0, 8. Connect the dots and make it look exponentially. Right, Shobi? Okay, look, buddy. All right, what's the domain of this and every other exponential function? All real numbers, we can also write that as -infinity and +infinity. Marmy, what's the range of this function? ¿Qué es lo que es el rango de la función? Remember, range are all the y's. What are all the y's? Meaning, how low does this graph go and how high does it go? Why -infinity? It's not going to -infinity. Okay, well, you can say -1, +infinity, or an easier way, which is fine with me, is to say y greater than 1. Any one of those is fine. You do not need to write both, unless you're n. Is this function increasing or decreasing? It is only increasing, yeah. So it's increasing everywhere. So increasing -infinity, +infinity. It is not decreasing anywhere. Where's the y-intercept? Where am I crossing the y-axis? At 8, good. If you put 8, that's fine. If you put 0, even better. What do you think ha stands for? Horizontal asymptote. Jason, where's the horizontal asymptote? Ingrid's already even said it. It's the second time you've been asked for this in this problem. You know that when Ingrid speaks, people listen. Y equals -1. As x goes to -infinity, that means you're going left. X, -infinity on the x-axis means left. What is the left arrow doing? No. Left arrow. Hey, look at me. I'm the left arrow. Where am I going? Oh, it's up or down. They want to know g of x means the y. So it's either going to be up or it's going to be down. It's obviously going down, but how far down is it going? It's going down to the asymptote, which is at -1. So all you would have to put is -1. But if you want to be fancy schmancy, you know, sometimes you put a little superscript up here with a plus, saying that it's going to -1 from the top side, not from the bottom. And then as x goes to +infinity, that means as you're going right, what is the right arrow doing? It's going positivo infinity. What is the value of function g at 1? Yeah, that one we didn't find, so that one we'd have to find manually. It's not on the graph. So what Marquise did was he just went up here and plugged in a 1. We don't have a choice there. 1. So if I were to show the work. G at 1 is equal to 3 at I'm plugging in a 1 for x, so 1 plus 2 and then minus 1. 1 plus 2 is, so 3 to the third minus 1. What's 3 to the third? 27 minus 1 is 26. And I'm going to skip that next one because that's not a fair question for you. You got the answer?
Yeah.
Why? Because of the graphing calculator?
Yeah.
Oh. Yeah, because you guys haven't learned logarithms. To solve that algebraically, you need to either learn logs or learn common bases, but I'm not going to cross that bridge. So that's not going to show up on the test, and if it does, I'll take it out. That's not a fair question for an Algebra 1 student. If you can see it on the graph, yes, it's fair. If 80 was part of the graph, like it was on the quiz, that's fair game. I don't have a problem with that question. But to ask you to find the x, you have to know what a logarithm is, and we haven't done logarithms. So don't worry about that. Describe the transformations of the function negative 4 to the x plus 2. Okay. Brian, we're going to identify a, h, and k, but then we're also going to describe what that means. What's a here, Brian? Good, negative 1. What is h? Good, and what's k? Now, whether we're doing exponentials, whether we're doing quadratics, whether it's this unit, last unit, once we know what a, h, and k are, they're going to do the same thing. I could have asked you this question almost a month ago, like right when we got back to school 3 weeks ago, and you should have been able to answer it. So when a is negative 1, what has occurred? Good, only an x-axis reflection, nothing else for that x-axis reflection. Reflection. How about when h is negative 2? Translation. Use keywords. Translation. That's 2 units. Okay. Number, and that's it. K 0. Number 3, same thing. A, h, and k. Show me. What's a for number 3? Good. And what's h? Maybe I change the sign. Positive 3. What's k? So this has 3 different transformations. Let's list them all. Kai, what's the first one? Good. Vertical stretch of 2. Vertical stretchy pants of 2. Sam, I am. What's the next transformation? Very good. The right 3. And then finally the last one, Brandon. That's translation up. Oh. Okay, 4 and 5 look like open-ended questions, which means that Actually, no, I take it back. It's not really open-ended. Everybody's will look the same because they're telling you what to do with the error rate. But you have to write it. Now it's backwards. They're giving you the transformations, and then you have to plug them in. So if I went up 4, that means that k is 4. If I went 2 to the left, that means that h is -2. And that's it. So that means a is 1. I don't say anything else. So if this is the parent function, I don't need to write a because it's in front. I would write 1/2. But instead of to the x, what would I write? Instead of to the x power, what would it be? X plus 2. In the little letters. An exponent. And then the big one at the end plus 4. But wait, mister, you forgot to write g of x. No, it's just because it was written for me already. So like Marquise, if this were a test and it's not written for you, you have to make sure you write it. I just didn't write it because it's already there. Create an equation g of x that is translated 1 unit down. So what does that mean? If it's going 1 down, what does that mean? What's -1? Okay, good. 3 units to the right would be h is 3, and is reflected over the x-axis. It would be a is -1. Excellent. I don't need the 1, but I do need the negative in front. Instead of 2 to the x, I'm going to write 2 to the x minus 3, and then fax machine. Okay, next page. Consider this function. What is the parent function there? The papa function. Yeah, 1/3. So they don't tell us what to call it, but let's just call it f of x is equal to 1/3 of the x. That's with no transformations. But now let's identify the transformations. A, H, A. What's A here? -1. Good. Read, what's H? No, H. What is H? 0. Good. And what's K? 1. So what transformations are occurring here? Yes, ma'am. Oh, okay, yeah. X-axis reflection. And go ahead, Kiara. Give me the other one. Up, down. Yeah. Translation. Up. Okay. All right. Now let's graph. You know, the way that this is set up is that they want you to plug in these numbers and see what you get. I like to pick my own numbers, so let's do that. What type of a function is this? A decay, so I suggest putting in 0 and negatives, -1, -2, -3. And a -3 is not going to hold. So let's just leave it at 0, -1, and -2. 1/3 to the 0 power is 1. What's 1/3 to the -1? The negative flips it. So 1/3 to the -1 is the same as 3 to the 1, 3. 1/3 to the -2 is 9. each of these points, I'm going to get the y's and multiply them times -1, and I'm going to also add 1. The x's stay the same. Nothing is going to happen to the x's. So 0 stays the same, but it's 1 times -1 plus 1. What's 1 times -1 plus 1? It is 0, so 0, 0. I know 1 point is going to be 0, 0. The -1 stays the same. What's 3 times -1 plus 1? -2, good. Simple math. So -1, -2. Finally, the -2 stays the same because h is 0, so that the x is not being affected. What is 9 times -1 plus 1? -8. If I tried to do what they wanted me to do and put a 1 in, I get a fraction. I know you guys don't want to deal with fractions. If I do what I wanted to do, which was put in a -3, I would get a number that doesn't fit on the graph. So fine, let's just go with 3 points. 3 points should be enough. Ingrid, where's my asymptote going to be? At where? Good. And then 0, 0, -1, -2, -2, -8. Connect the dots. Sam, what's my domain? Good. Or you can write all real numbers. It's fine. Oh, why don't you guys put like ARC or something? I don't know what the heck that meant, but can we just either write out all real numbers or just put -infinity, +infinity? Before we answer the range, Jason's going to answer the asymptote. And then he'll answer the range too. Where's my asymptote going to be at? Yeah, it is going to be at y equals 1. So therefore, what's the range, Jason? Or JV as his friends call him. Ingrid, ¿dónde está el range? What's the range? Martha, range. It's not going to positive infinity. Look at that. It's going down forever. You cannot, if you're overthinking this whole infinity thing way too much, then don't use interval notation. Just put, hey, look, the entire graph is less than 1, so write down y less than 1. I will take it. I don't know what other teachers do. I will take it. It's fine with me. But if you want to get fancy and use interval notation, then it would be negative infinity would come first, and then it goes up to all the way to 1. Got to go from smaller to biggest. Is this increasing or decreasing? It is actually increasing, yeah. It started off as a decay, but it flipped, so it's increasing forever. It's limited, because it'll only go up to 1, but it is increasing, it's not decreasing. How about the y-intercept? Where is it touching the y-axis? At 0, 0. Coincidentally, that's also the x-intercept. What's the left arrow doing? As x goes to negative infinity, what's the left arrow doing? It's also going to negative infinity with the y, yeah. It's going down forever. What's the right arrow doing? It's not going to positive infinity. It's going to the asymptote, which is 1. If you write 1, that's fine. But see, this is what I was telling you. Don't get this confused. And if you have to, then just strike it from your memory. All right? Nakai is correct. That is positive 1. But is it approaching positive 1 from above? Is it coming down, like coming down from above? Or is it going up from below? Yeah, it's coming from below. So you will probably see like a little minus there, which doesn't mean negative 1. It just means that it's coming up from underneath it. You don't have to put that. Some people just like to know. Facts. What is G at 2? Well, see, that we can find. I don't have a problem, even though I can't see that on the graph, to be sure. You know, I don't have a problem with you guys finding algebraically when they're giving you the X. When they're giving you the Y, I don't think it's fair. But when giving you the X, yeah, it is. What's 1? Here, let's do it here on the side. G at 2. Do you have this one? No! Okay. Negative 1/3 squared plus 1. What's 1/3 squared? 1/9. Yeah, the negative stays in front. So I have to add 1/9 plus 1. In order to add fractions, what needs to be true? Common denominator. So that's negative 1/9 plus 9/9. So all the children rejoice when they find out that it's 8/9. We'll stop there. And then, like I said, tomorrow you just let me know whether you want to, you know, we can do some combination. I can maybe finish the second page and then let you work on the Chromebooks. You just work on the Chromebooks, just work on this, just think about it. I'll have them here anyways because my other classes are going to be using them.